All right, so here's a quick attempt at finding the volume of a bicylinder. So I rendered it here in Mathematica. You can see from one direction we see a circle, from another direction we see a square. So it ends up being a volume of solid with known cross-section. So what I did was I cut it in half so I could look at the top half, so I can find the volume of that and double it. But actually I can cut that in half and now multiply by 4, that's a quarter of the full solid. And then finally I can cut that in half. So now I've got an eighth of the full solid, and you can see that my base is going to be a semicircle, and my cross sections perpendicular to the x-axis, if you can turn it right, are going to be squares. So it becomes a little calculus question. Find the volume of the solid with base. Typo, I'll leave that there. On the circle x squared plus y squared equals r squared in the first quadrant with cross sections perpendicular to the x-axis that are squares. And then I'm going to find that and multiply by 8. So here's the diagram I use. Here's the base. This is an xy base, and I'm cutting this way. So I'm going to copy that segment just to make my point. I'm sort of pulling this segment over here. I'll turn it so I can see it a little better. Try not to change the size. And that length then, since this equation is y equals r squared minus x squared, that's what this is. This is root r squared minus x squared. Now in this case I will have cross sections that are squares, so that's going to be here. So this side's also going to be root r squared minus x squared. So the area of that cross section is just r squared minus x squared. And so I'm going to integrate from 0 to r, and I know that I'll talk about my whole figure now. So 1/8 the volume of my entire solid is equal to the sum of those areas. So the integral from 0 to r of r squared minus x squared dx due to calculus. So we get an r squared x minus x cubed over 3 from 0 to r. And I substitute in, and I get an r cubed minus r cubed over 3. And I always like my students to write a minus 0 minus 0 even, just so they've been thinking about that. That's got to go in there. So now I have a 2/3 r cubed, and that's 1/8 of the entire volume. So that means the volume of the bicylinder is 16/3 r cubed. Ta-da!